Hi everybody, let's do 7th grade DD.6. So we will go to Learning, scroll down to 7th grade, scroll down to DD6, make predictions using theoretical probability, which is basically the same as DD5. All right, let's go ahead and just read a little bit of the reference page on probability, which is page 11. All right, and the only thing we're going to need here is how to make a prediction. So we're going to make a prediction, we multiply the probability of the event or compound event. Compound event means that more than one thing is going to happen. But I believe these are all simple events here. So we just have one bag of marbles, or we just have a coin. In any case, we multiply the probability with the number of attempts. Alternatively, so another strategy is to set up a proportion. So on one side of the proportion, we have the probability, which is this good over total here. And on the other side of the proportion, we have x, which is what we're looking for, over the number of attempts. The number of attempts just means the number of times we're going to try something, whether that's pulling a marble out of a bag, or flipping a coin, or spinning a spinner, whatever it is. All right, so let's go ahead and try some problems. You select a marble without looking, and then put it back. If you do this 9 times, what is the best prediction possible for the number of times you will pick an orange marble? All right, so the first thing we need to do here is figure out the probability of picking an orange marble. So we'll do our good over total fraction, which tells us the probability. How many, remember we want an orange marble. Orange marbles are good for us. How many orange marbles are there here? There are 0 orange marbles. There are no orange marbles there, so we'll put 0 over here in the fraction. Out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles. Now, when the numerator is 0, the denominator doesn't even matter that much. But anyway, the probability is 0 out of 9, which is equal to 0 and also 0%. So we have a 0% chance of selecting an orange marble, which makes sense because it's impossible to select an orange marble because there are no orange marbles. Now, if we reach into the bag 9 times and pick out a marble each time, how are we going to do that? We're going to reach into the bag. We're going to close our eyes and reach into the bag, pick a marble, and then open our eyes and look at the marble and see what color it is, and then put the marble back. Then we close our eyes again, pick a marble, we look at the color, we put it back. We close our eyes again, pick a marble, and so on. We do that 9 times. So we're picking out 9 marbles and putting them back every time we pick them out. Out of those 9 times, how many times would we expect to get an orange marble? Well, to figure that out, we're going to take our probability, which is 0. You could use the fraction form, or you can use the decimal form. So we just have 0 times, remember we're going to do this 9 times. So we have 0 times 9, which is equal to 0. So the best prediction that we can make is that if we pick 9 marbles, 0 of them will be orange marbles, which makes sense because there are no orange marbles. Another way we could have done that is to set up a proportion. 0 over 9 equals x over 9. This 9 is coming from the total number of marbles. This 9 is coming from the fact that we picked out a marble 9 times. Another point of confusion might be this x is an unknown, which we're trying to figure out. This x from the multiplication strategy means multiplication. So these two things are different. Cross multiply here, 9 times 0 is 0, and then equals 9 times x is 9x. To get the 9 away from the x, we would have to divide. So divide both sides by 9. That cancels. X equals 0 divided by 9 is 0. So once again, we see that our prediction is 0, which makes sense. If you flip a coin 6 times, what is the best prediction possible for the number of times it will land on heads? Well, if we flip a coin, the probability that the coin comes up heads is 1 out of 2, because there are two sides to a coin, heads and tails, and one of those sides is heads. So that's the probability there. That is also equal to 0.5 or 50%. Now, let's say you had a coin in your hand. You can go ahead and get a coin if you want to. Maybe you have a quarter in your pocket. If you flip the coin 6 times, how many times would you expect to get heads? What is the best prediction you can make? Of course, we don't know for sure. It's possible that we get heads 0 times. It's possible that we get heads all 6 times. It's possible that we get heads 5 times. But not all of those predictions are very good predictions. I'm probably not going to get heads all 6 times. It might happen, but that's not the best prediction I can make. What's the best prediction I can make? Well, to figure that out, we take our probability, which is 1/2, and we multiply it by the number of times we're going to be flipping the coin, the number of attempts, which is 6. That came from right over here. Put the 6 over 1, we get 1 times 6 is 6, and 2 times 1 is 2, and 6 divided by 2 is 3. We also could have used this number over here, 0.5 times 6. 6 times 5 is 30, carry the 3. 6 times 0 is 0, plus 3 is 3. And then we have 1 space here, so 1 space there. So we get 3.0, which is the same as 3. Okay? So if I flip a coin 6 times, it's reasonable for me to predict that 3 of those times the coin will come up heads. Another way that I could have done that is to take the probability, 1 over 2, and set it equal to x over 6. Then cross multiply, we get 6 equals 2 times x. Divide both sides by 2. And we get x equals 3. All right, so that was using this strategy over here of setting up a proportion. It gives us, as you can see, the same answer. All right, let's try another one here. If you roll a 6-sided die 6 times, what is the best prediction possible for the number of times you will roll an even number? All right, so again, we're going to start out by trying to find the probability of getting an even number. Now, before we do that, we need to think to ourselves, what are the numbers on a six-sided die? Well, a six-sided die, also called a number cube, is something like this. You've probably seen it if you've played Monopoly or backgammon. It's got numbers on it. Okay, the numbers are 1, 2, 3, 4, 5, and 6. Now we want an even number. An even number is a number that is divisible by 2. Meaning, if we take that number and we divide it by 2, then we get a whole number. We don't get a decimal like 4.7. Okay, so if I do 1 divided by 2, I get a decimal, I get 0.5. So that's not an even number. If I do 2 divided by 2, I get 1, which is a whole number. So 2 is an even number. 3 is not an even number. 4 is an even number. 5 is not an even number. 5 divided by 2 would be 2.5, so I get a decimal there. 6 is an even number. 6 divided by 2 would be 3, a nice whole number. So, how many even numbers are there? 1, 2, 3. So if we want an even number, then there are 3 good numbers for us. How many numbers are there total? That would be 6. There are 6 numbers total on a number cube. So the probability of getting an even number is 3 out of 6. And if we do 3 divided by 6, that's also, like in the last problem, I think it was the last problem. I might be remembering wrong. Anyway, 3 divided by 6 is 0.5, which is 50%. Okay? That's not the answer, though. That's just the probability. We are going to roll this number cube 6 times. Out of those 6 times, how many times do we think we would get an even number? Again, we might get an even number all 6 times. We might get an even number 0 times or just 1 time. But not all of those predictions are very good predictions. Even if they can happen, the best prediction we can make, the most reasonable prediction, would be to take the probability and multiply it by the number of attempts, which in this case is 6. Put the 6 over 1 there. We get 18 over 6, and 18 divided by 6 is 3. So again, the best prediction possible is 3. Proportion strategy would look like this. Three again. Okay. Next problem. You select a marble without looking, no cheating, and then put it back. If you do this 4 times, what is the best prediction possible for the number of times you will pick an orange marble? The probability of picking an orange marble here, well, there's 1 orange marble, and there are 4 total marbles. So that would be 1 over 4, or 0.25, or 25%. You don't have to write all the different ways. It's just nice to see it. Okay, so we have a 25% chance of getting an orange marble. So if we close our eyes and pick a marble out of the bag, we're probably not going to get the orange marble. 25% is less than 50%, so that would be unlikely, but it's possible. The orange marble is there, so we might get it. Now, we have 4 chances. Well, we're going to do this 4 times. We're going to pick a marble, look at the color, and then put it back. Pick a marble again, look at the color, and then put it back. Pick a marble again, look at the color, put it back, and then pick a marble again, look at the color, and put it back. So we did that 4 times. Out of those 4 times, how many times would we predict that we would get an orange marble? We'll take our probability. We could use the fraction. We could use the decimal. It doesn't matter. I'll use the decimal this time. Multiply it by the number of attempts. We're going to multiply by 4 here. The reason I'm using 4 is not because I have 4 marbles. It's because we're going to do this 4 times. 5 times 4 is 20. 4 times 2 is 8. Plus 2 is 10. 4 times 0 is 0. Plus 1 is 1. And then 1, 2, 1, 2, 1. So if I pick a marble 4 times, I would predict 1 time to get the orange marble. That seems like a reasonable prediction. I might get the orange marble all 4 times, but that's probably not going to happen. A better prediction would be that I just get the marble once. Again, we could also set up a proportion. 1 over 4 equals x over 4. 4 equals 4x. Divide both sides by 4. X equals 1. All right. Okay. Let's go ahead and jump to the next level. Let's see. So this would be, if you spin the spinner 9 times, what is the best prediction possible for the number of times it will land on blue? So let's see. 1, 2, 3, 4, 5, 6, 7 blue out of a total of 9. So that would be 7 over 9 times 9. And you would get 7 for that one. All right, these look to be about the same. So I'm just going to jump ahead to the next level. Let's see if... Okay, again, it's the same type of a problem. I'll do this one and see if there are any different ones here. You spin the spinner 48 times. Okay, so you have a lot of free time on your hands. Just sitting at home spinning spinners all day. What is the best prediction possible for the number of times it will land on green or pink? Okay here. So this one is a little bit different. Good. We have not talked about this yet. Actually, I need to go back. Sorry, I need to go back to the reference page for a second. All right. And I'm looking back over here at finding a simple probability. So we've done good over total 1,000,000 times in these videos already. But I want to read ahead. Let's just go ahead and read this again because there's something important here. If more than one outcome is considered good, add them all up. So that's like over here. Green is good, but pink is also good. So in order to find the probability, we need to add the probabilities together. Let's go back to this example. For example, suppose there is a bag with 2 red marbles, 5 yellow marbles, and 2 blue marbles. The probability of picking a red marble is 2/9. The probability of picking a red or yellow marble. So let's imagine that a red marble is good. If we pick a red marble, we win a prize. And if we pick a yellow marble, we also win a prize. So red and yellow are both good. So the probability of picking a red or a yellow marble would be 2/9 plus 5/9, which equals 2 plus 5 over 9, which is equal to 7/9. Using that knowledge, let's try this problem now. So what is the probability? I'm going to write it this way. The probability of getting a green or a pink, of landing on green or pink. Well, the probability of landing on green is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of, there was a total of 12 wedges here. The probability of getting pink was, there's only one pink space there, so 1 out of 12. So to find the probability of getting green or pink, we would add these two probabilities together, which means we add the numerators and keep the denominator the same. 11 plus 1 is 12, so I get 12 out of 12, which is equal to 12 divided by 12 is 1. As a percent, that would be 100%. So I have 100% chance of landing on green or pink, which of course makes sense because all of the colors are either green or pink. So if somebody tells me to spin the spinner, and if it lands on green or pink, then I'm going to, let's say, win a stuffed animal or win a teddy bear, I'm definitely going to win because all of those wedges are either green or pink. So I have 100% chance of winning. I can't lose. Now, if I spin the spinner 48 times, how many times would I expect to land on green or pink? Well, to do that, again, we just take our probability. I'm going to just use the number 1 here because it's easier. So I take the probability and I multiply that by the number of attempts, which is, in this case, 48. I'm going to do this 48 times. Out of those 48 times, how many times would I expect to land on green or pink? Well, 1 times 48 is 48. So I would expect to land on green or pink 48 out of the 48 times that I try that. In other words, I would expect to land on 48 every single time, which again makes sense because all of these colors here are good colors for me. So I'm going to win every time. So if I spin the spinner 48 times, I'm going to win 48 times. So that's my prediction. If you flip a coin 6 times, what is the best prediction possible for the number of times it will land on heads? I feel like we've done this one before. That would be a half because I have flipping a coin is I have a 1 out of 2 chance of getting heads. If I do it 6 times, multiply by 6. Didn't we do this exact same problem? I don't know. Anyway, that would be 6 divided by 2 is 3. Okay, I feel like we've done problems like that, so I'm just going to do that one quickly. Okay, here. Yeah, we've done problems like this before. If you spin the spinner 72 times, what is the best prediction possible for the number of times it will land on pink? Well, you know what? We don't have to go through everything for this one because we can see there are no pink wedges here. I can't land on pink. So it doesn't matter how many times I spin it. If I spin it 72 times, I'm going to land on pink 0 times because there are no pink wedges here. So I could spin this thing 10 billion times. It wouldn't matter. I can't land on pink, so the answer has to be 0. Okay, this one's a tricky one. So let's go through it. If you spin the spinner 5 times, what is the best prediction possible for the number of times it will not land on green? All right, be careful here. How many of these colors, how many of these sections are not green? This is, remember, it says not green. We do not want to land on green. This is not 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 green. So there are, if I do good over total, there are 5 wedges there that are not green out of a total of 5 wedges. So again, if I spin this spinner, I have 100% chance of landing on a section which is not green because all of them are not green. So again, I can't lose. If I spin the spinner 5 times, how many times do I think I'm going to land on something which is not green? Again, that would be 1 times 5 equals 5. Of course, all 5 times I'm going to land on a space which is not green because none of them are green. So I'm going to win all 5 of these times. You could have also done that by using this fraction over here. If we had done 5 over 5 times 5, and then put this 5 over 1, we get 25 over 5, and 25 divided by 5 is 5. So again, we get the same answer, right? You could also use the proportion strategy for that. 5 over 5 equals x also over 5. There are a lot of 5s in this problem. We would see that 25 is equal to 5x. Divide both sides by 5. Again, x equals 5. So there are 5s all over the place in this problem. There we go. Okay. If you roll a 6-sided die 24 times, what is the best prediction possible for the number of times you will roll on an odd number? An odd number is a number that is not divisible by 2. So, on a number cube or a die, we have a 1, a 2, a 3, a 4, a 5, and a 6. 1 is odd, 3 is odd, and 5 is odd. Those are all the numbers that are not divisible by 2. So our probability is going to be 1, 2, 3 out of 1, 2, 3, 4, 5, 6. And if we take that and multiply by the number of attempts, how many times are we going to be rolling this die? We're going to roll it 24 times. Okay. So in that case, we would get 72 over 6, which is equal to 12. Okay? We also could have reduced this. So if we divide this by 6 and divide this by 6, then we get a 4 here, and we get a 1 here, and 3 times 4 is 12, and 1 times 1 is 1, and 12 divided by 1 again is 12. So that's another way that we could have done that. We also can set up a proportion here. 3 over 6 equals x over 12. I could cross multiply here. I think there have been enough examples of me cross multiplying in these videos. Another way that I could solve this proportion is to say that, oh, I'm sorry, this should not be a 12. That should be a 24. Okay, whoops. All right, so 6 times what number is equal to 24? That's 4. And 3 times 4, again, 3 times 4 is also 12. Okay, so that's another way that we can get the 12 there. So if we roll the die 24 times, we would expect an odd number to come up about 12 times. Now, if you actually do this, are you definitely going to get an odd number 12 times? No, you might get an odd number 13 times. You might get an odd number 9 times. It's possible that you get an odd number all 24 times, but that would be pretty unlikely. The best prediction you can make is to say 12. That's, so if you had to bet on it, the best bet to make would be 12. Okay, this problem I think is like the other one. So this one, the best prediction, if we spin this spinner 66 times, how many times do we think it would land on green? That would be 1 out of 3 times 66, which equals 22. Right? All right, let's go ahead to the next level. Well, okay, let's do this one. I like this one because I got another OR problem here. So the number of times, if I spin this spinner 70 times, what is the best prediction possible for the number of times it will land on yellow or blue? So if it lands on yellow, that's good. If it lands on blue, that's also good. So the probability of landing on yellow or blue, well, there are 1, 2, 3 yellow wedges, and there are 1, 2 blue wedges. And if you remember from before, what we're going to do is we're going to add these up in the numerator there. And the total number of wedges is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get here 5 out of 10. And let's just go ahead and set up a proportion. So 5 out of 10 equals x over, how many times are we going to spin this spinner? 70 times. So if we spin the spinner 70 times, how many times would we expect it to land on yellow or blue? Well, half of those colors are yellow or blue. What's half of 70? Half of 70 is 35. Let's see if that reasoning works here. If we do 10 times 7 is 70. 5 times 7 is 35. So yeah, we can see here that the best prediction we can make is that the spinner will land on yellow or blue 35 times. We also could have cross-multiplied. We get 350 equals 10x. Divide both sides by 10. X equals 35. Same answer. All right, let's jump ahead to the next level. See if there are any different types of problems here. This is the same kind of problem. If you spin the spinner 66 times, how many times, what's the best prediction for the number of times it will land on green or pink? Well, all of those colors are green or pink, so we can't lose. So if we spin the spinner 66 times, it's going to land on green or pink all 66 of those times. That was an easy one. All right, I think this is the last one that I'm going to do because I think the problems are pretty similar here. If you spin the spinner 77 times, what's the best prediction possible for the number of times it will land on pink or blue? I'll do another one just so we can see another or problem. So again, it's like I'm going to a carnival, and every time I spin the spinner, if it lands on pink or blue, I get a prize. So if I spin the spinner 77 times, how many prizes am I likely to get? Well, let's see. There are 1, 2, 3, 4 pink wedges plus another 1 blue wedge out of a total of 1, 2, 3, 4, 5, 6, 7 wedges. So there are 5 out of 7 wedges which are good, right? I'm doing this backwards here. I'm writing good over total as the last thing that I do. Okay, so the probability is 5 out of 7, which is a pretty good probability, right? 5 divided by 7, by the way, is about 71%, which is more than 50%. So if I'm playing this game, I will probably win a prize every time I spin that spinner. I'm not definitely going to win the prize, but the odds are in my favor, okay? All right, now if I spin the spinner 77 times, how many out of those 77 times am I likely to win a prize? Okay, so we can multiply here. You know what? Let's just reduce this a little bit to make our lives easier. This number and this number we can divide by 7. We get 11 here. We get 1 here. So 5 times 11 is 55. And 1 times 1 is 1. And 55 divided by 1 is 55. So if I spin the spinner 77 times, I'm probably not going to win a prize every single time, but I would predict that I would win a prize about 55 times. Maybe I win 60 times, maybe I win 40 times. Again, I don't know for sure, but the best prediction I can make is that I would win about 55 times. All right. We could also set up a proportion like this. And to do this the easy way here, 7 times 11 is 77. So if I do the same thing in the numerator, 5 times 11, 5 times 11, again, is 55. So we can see that we get the same answer using the proportion strategy. Let me check to make sure that I am recording. I really hope I haven't been talking to myself this whole time. Okay, good. I'm still recording. Nice. I hope you enjoyed it. I hope you're still with me. I know that was a lot to listen to. Have a great day.